Hello, this is Denton Yoder, instructor for BSE 2304, the Biological Systems Engineering CAD class. This topic will be on Cogo, and that stands for Coordinate Geometry. It was officially MIT created artificial intelligence type, well, not really artificial intelligence, but just a math calculation tool from the 60s. It was well in use in the 80s. I'm going to argue that it's not really needed anymore because we can use CAD as a graphical calculator instead of having to have some kind of program to do the calculations. A couple places where Cogo tools are still important might be doing a least squares best fit on lines or curves, or some of the spiral calculations you might still want to do by hand. But anyway, jumping into CAD, let's say I wanted an arc 200 feet long with a height of 50 feet. Typically, I would just draw a line, make it 200 feet long, then draw a line from the middle of it, straight out 50 feet. And now I can put an arc through those endpoints. And I have the properties. Control 1 gives me properties for that arc. The grayed out sections in the properties are calculated properties. The computer stores the center point, the radius, and the starting and ending angles, but then it'll tell you the total angle or degree of curvature and the arc length as well. In the old days, we used to write our own tools to do that type of thing. One of the tools I wrote, let me load up Line Lab. I originally wrote it just for lines, but then I expanded it to do arcs as well. If I do a Line Lab, line label, click my arc, it gives me the same information, but it also includes a chord length and a chord bearing, which we really haven't talked much about bearing. A lot of the Cogo tools were to put points in on a bearing and a distance. We learned in the early weeks of CAD how to do a line with an angle and a distance. It was at, distance, less than, angle. We can still use that with a bearing. If I put a line in right here, I can say at 273, angle north 75 degrees, 30 minutes, 10 seconds east. So I'm, for an angle, instead of putting in a degrees, I'm putting in north 75D, 30 foot tick, 10 inch tick east. And what that tells AutoCAD to do is to draw a line 273 feet long at that bearing. And I can do my Line Lab, click the line, and it'll label it for you, and you can see that it is 75 degrees, 30 minutes, 10 seconds. So AutoCAD lets us put bearings in. Oh, that's the code running. You flip up to the top of that. With an at, distance, less than, angle, and I can use a bearing in my angle. So not much need for a graphical calculator. The line label program we used to use all the time for labeling property boundaries. You would put a property boundary in, and then you just do Line Lab to label them. You pick towards the end that is your from point. Okay. Other calculations we can do with the computer. If I have a coal stockpile, and I know the stockpile's bottom width is 35 feet, and I know the height of the stockpile is some unknown value. I don't know how tall it is, but I know that the side slope is on 20 degrees. Well, I can draw a line and say at some arbitrary distance, angle 20, and what that did was drew a line on 20 degrees, and if I use fillet with a 0 radius as a corner cleanup, I now know the distance, di for distance, to the top is 6.3695. I have the height of that stockpile. And if you wanted a 3D volume, of course you could do the math, but I'm advocating that we don't need to do math. I'm going to do the region command. REG is the region command. I'm going to region that, and I'm going to REV, revolve that around its center point, 360 degrees. Now that is a 360 degree object with a mass property, mass prop, and I get a volume. So I know I have 2,042 cubic feet in that object. And okay, let me erase that. Circles or fillets. Let's say I have a line here and I have a line here, and I want a 250-foot radius between them. The fillet command, fillet radius 250, pick the line, nothing fitting. Okay, it says my radius is too large. Let me zoom out a little bit and make these bigger. I'm doing a grip edit is what I'm doing on these right here. Fillet, click, click. So now I calculated in that circle. What we used to do in the old days is we would actually fillet items with a radius of 0, and then we could put in a circle tangent radius, circle TTR, and I can say tangent to here with a radius of 250, and you basically did the same thing, except I need to trim. Fillet was quicker. Okay. In the built-in software, you can also label things. Their labels may actually even be better than mine because they understand scale. Let me just do some of their labels. So what I'm going to go to is on the annotate ribbon bar. There's an add labels, and it has labels for surfaces, figures, parcels, blah, 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 blah. Clear down at the bottom is lines and curves. I can add line and curve labels. I usually say I want multiple segments, and I like bearing over distance. For curves, you can have different things. You want the distance, radius, and delta. That's fine. That's about all it gives you. And I'm going to hit add. Now when I pick my line, my curve, and my line, I get the bearing over distance and the curve information, bearing over distance. They're showing the seconds with 2 decimal places. That seems a little extreme, and I don't know anybody that does 3 decimal places on their regular distances, but those would be in the units. We could change that. Now the thing I wanted to show you here is if I switch to a different scale of, let's say, 100, the text gets bigger automatically. So these are intelligent objects. If I, okay, this is 1,171 feet. If I drew a line down here, and said extend to that boundary, it's now 2389. So these labels are attached to the line, they grow with the line, and they are scale dependent, so they will resize automatically if you change your scale. So they're pretty slick. Okay, I think that's it for Cogo and coordinate geometry and calculating and labeling. Next, we're going to do some points. I'll get into that in just a minute. Bye.